Hi, I'm Sriranjani Ramkumar from Product Marketing here at MathWorks, and welcome to the video on getting started with the general purpose input-output for Renesas RA Microcontroller. Microcontrollers come with built-in peripherals that extend their capabilities such as GPIO, ADC, PWM, and so on. Today, we'll focus on GPIO, which allows you to connect and control external devices like sensors, switches, LEDs, and motor. In this video, I'll quickly walk you through the basics of GPIO, followed by a hands-on where I'll show you how to build and deploy your first model using Simulink and the embedded coder support package for RA microcontrollers. To begin, GPIOs are general purpose input-output pins, and it can be configured to read digital signals or output digital signals. It can also be used to configure for alternate functionality such as to generate PWM signal, read or output analog signals, trigger to interrupt, etc. Let's narrow our focus on how to configure GPIO to read or output digital signals. In Simulink, for Renesas RA6T2, there are two Simulink blocks, digital port pins read and digital port pins write. In this video, let's see how to configure a GPIO as an output pin using digital port pins write block. Next, let's move on to the main section of the video. The hands-on to configure the GPIO as an output pin using the digital port pins write block with a classic exercise blinking an LED on an RA62 controller. The workflow is to begin modeling in Simulink where the functionality aspect of the LED blinking is modeled and use Renesas RA Smart Configurator to configure the peripherals. After generating the configuration XML file, include the same in the Simulink environment. Then proceed to build, deploy and start the model to see the LED blinking on the controller along with the generated C code. Let's first set up the hardware. It's super simple. Just plug the RA62 controller into your computer where the MATLAB is installed using an USB cable. With the hardware setup, open the Simulink and start a new model. In the library browser, expand the embedded coder support package for RA microcontrollers. Drag and drop the digital port pins write block onto your canvas. Add a pulse generator and set the following parameters in the block configuration. Double-click the digital port pins write block to configure the port and pin settings. The port value ranges from 0 to 15 and it can be specified in decimals such as 0 to 15 or in an hexadecimal format such as P0, P1 to P9 and PA to PF enclosed in a single quote. Here, let's enter PD for port and 1 for the pin, which corresponds to the port and pin number of the LED 1 of the first inverter board connector CN5. Press Ctrl E to open the configuration parameter and configure the model for your hardware so that the model is built and generates code tailored for the RA62 controller. Go to the Hardware Implementation tab, select the board and the device series. To set up the peripherals of RA62, we leverage the Renesas RA Smart Configurator tool. Expand the target hardware resources and under the build option, you can either create a new RASC project by clicking on create or locate an existing project and launch it to view the settings. For this example, let's quickly create a new project. Provide a title for RASC project and browse to the location where the project will be created. Once created, the configuration.xml path is automatically added. Now, click on Launch to configure the peripheral. In RASC, there are multiple tabs starting from Project Summary, BSP to Stacks. Here, let's take a closer look into the Stacks tab. By creating a project from Simulink, it automatically generates stacks for GPIO, SCAUART and external mode timer by default. Next, go to the Pins tab and configure the pin 01 of port PD, which was previously mentioned in the digital port pins write block in Simulink, and set it to output mode with an initial high state. Save the settings to update all the changes in the generated XML file. Close the RASC and switch back to the configuration parameters for further settings. Under Code Generation, click on Report. Enable the code generation report and traceability. With the hardware board selected in the configuration parameters, a new hardware tab appears in Simulink, displaying the selected hardware board. With everything configured, let me quickly save the model and proceed for deployment. Click on Build, Deploy and Start. This builds the model, generates code and deploy your model onto the microcontroller, allowing you to see the LED blinking. Also, the code generation report opens automatically, where you will be able to locate the generated code in the file name ledblinky.c, which corresponds to a Simulink model tailored for Renesas RA62 hardware. The file contains three main functions: an initialization section that executes once at the start, a step function that runs continuously in the loop, and a terminate function that executes at the end. Additionally, traceability in the generated code provides direct links to the Simulink blocks, which helps to identify the blocks responsible for generating each section of code. And that's it. You have learned how to set up the digital port pins write block for Renesas RA microcontroller. I hope this video is helpful and thanks for watching this video.